These are examples of applying the first derivative test on problems where we're given the derivative already and we're not given the original function. So you do it the same way. The one thing we can't find are y coordinates because we don't know the original function. So we'll start with this first problem. We're given f prime, and we're looking for the x coordinates of the relative maxima of f. So you do it the same way we've always been doing it. We look for the critical numbers of f first, which is where the derivative equals 0. So since we're already given the derivative, we set that equal to 0. We find the critical numbers. It's already factored, so that's pretty simple. And then we set up our chart. This chart should have the critical numbers in order: -7, -2, and 2. We're going to set up a test number in each interval to test the derivative at. So it can be any number in the interval. Your test numbers may be different than mine. It doesn't matter as long as they're in the interval. And you plug them into the first derivative. Now the first derivative is already factored for us. So this will be easy. You just use your properties of multiplication. If you plug in -10 into this first derivative, you'll get a -8 times a negative number cubed, which is negative, times any number to the 6th that's positive. So I don't even have to worry about that, the x plus 7 to the 6th. Whatever we plug in that, it's going to be positive. So a negative times a negative times a positive is a positive times a positive. So we're increasing that interval. And then you just continue with all the other numbers. So -4 times +2 is negative. -4 minus 2 is negative. Cubed is still negative. And then as we talked about, that last factor is always positive. So now here we have a positive times a positive, which is positive. When you plug in 0, you'll have a positive times a negative times a positive, which is negative. And when you plug in 5, you'll get a positive times a positive times a positive, which is obviously positive. Question was, where's the maximum? Well, maximum was when we go from increasing to decreasing, or the derivative goes from positive to negative. The only place that happened is right here. Therefore, we have a relative maximum at x equals -2. Now, normally we would plug that back in to find the y coordinate, but we can't here because we don't have the original function. So we're done with this problem. There are 2 more examples, and I'll present those in a different video so these don't get too long for you. There you go.